Yo, what is up, guys? Welcome back. Just kind of got off the stream, so I thought I'd make a quick recap video. So let's get straight into our Pokemon Sound. We got a Dratini today. Tomorrow we have the final evolution. I can't remember what it's called, but Dratini. Is it Dratini or is it something else? Dratini. No, I think it's something else. Dragonair. That's what it is. Dragonair. Take a look at the Dragonair. Brrrr! Brrrr! How's that sound, man? Brrrr! Let's see it again. Ooh! Ooh! How's that sound, man? But yeah. Appreciate the support today on stream. I streamed for about 2 hours today, so we only did 2 problems. First of all, we visited the problem of the day, and that I thought was a really tough problem. I thought about solving it a brute force way. It's getting lower acceptance rate. It was definitely a tough problem. Then I kind of thought about it using a BFS, and I think I spent probably about close to an hour and a half on the problem. It was definitely tough, but we did get there in the end. Well, no, we didn't get there in the end, sorry. We ended up leaving the problem just because I couldn't solve it. I tried to kind of fix my bugs with GPT a little bit to ask it what was going on. GPT couldn't even help me solve it, so I kind of just left it. You know, sometimes you just got to take the L and move on, and that's okay, and just come back to it another time. Eventually, I'll probably come back around to that problem, but other than that, it was a tough problem. And then we looked at a graph theory problem. We looked at the which one was it? Oh man, I have to go back to my profile. What do we look at here? We looked at all nodes distance k in binary tree. So pretty much what the problem was it gave you a binary tree, and it wanted you to return the nodes that are at a certain k distance, right? So let's say 2, so a distance of 2. I had the right intuition of the problem. I kind of thought about converting it to an adjacency list, which it was technically a graph problem, but that was the first time I had ever converted a tree into a adjacency list for a graph problem. So it was a little confusing doing that, and then it was just a simple BFS traversal starting from the target node. So that was pretty straightforward. That problem we only spent probably about 10 minutes on it, so it was a pretty chill problem. And then we looked at the intersection of 2 linked lists. Obviously the solution here is really easy. I do feel that I'm pretty confident with linked list problems, but I just didn't get the intuition here. I hadn't looked in this problem in about 6 months. I solved it about 6 months ago, and you know, I was thinking about it when I was looking at it. If I go to the example, I was kind of looking at the problem here, and I was like, oh, well, there's no cycle. So how are we meant to use a fast and a slow pointer to make this work? But really, what the trick was is that you had to move to the next value if there was something there, or else you would change it to the other side, right? And you would keep looping it. Eventually, you'd make a collision. I still have my drawing up here. Oh, wait, no, I don't. I got rid of it. But eventually, you keep doing that. The nodes will come together, and you do it while A does not equal B, and eventually A and B does equal, and that is either our intersection or it's our none value where, it doesn't exist, where, we're going to get to a none value at the same time. So it was an interesting approach, but we did get there in the end, and it was a good stream today. So, again, thank you guys for the support. Thank you guys for watching. It's really nice having people help me on stream. Also kind of having some people just jump in and kind of encourage me to keep going. So thank you guys, and I wish you guys all the best in your journey too. So thank you guys, and I will see you on Sunday.